right, greetings and good evening, one and all. Hope you guys are all doing well on this wonderful Wednesday evening. I think it's Wednesday, at least that's what they keep telling me. Still trying to remember what day of the week it is. It's kind of tough when you haven't been to work in over 10 days. So, anywho, we're going to see what we can do tonight, working with rules of exponents. So I'll put it out there on Twitter for you guys, and that's what you guys voted on, so here we go. If at any time you have questions, just throw those in the chat. I'll be checking. I've got that right up here next to me, so it's really easy to see what's going on. I think, come on now. All right. All right, just some classic rules for exponents. Now, before you even get into rules for exponents, one of the things we need to remember is what is an exponent anyway. So we're just going to look at a basic expression like this. If I say, have this, x to the third power. A lot of times people would say this means x times itself 3 times. But really a better way of looking at it, a better way of saying it, is not to say x times itself 3 times, but to say that you would have three factors of x. So that is the better way of saying that. So when we have this expression, x to the third, we want to make sure that we remember that this guy right here is what we call the base. And this is your power, or we call it the exponent. Why is that not in focus? Hold on just a second here. Okay. Hopefully that will work. Let's check something out right here. Nope, don't do that. Okay, hopefully that will be better. Sorry about the word fuzziness. I'm still trying to get all this stuff figured out. All right, so anyway, there's your base and there's your power. And so that means if we were to take something like 5 to the third, that means that you have 3 factors of the base 5. Okay. Again, we don't want to say that we have 5 times itself 3 times. I think that, again, is too confusing. Let's make sure we use proper math terms. And so we say we have 3 factors of our base 5. So the thing here with exponents is that it's a shorthand way of writing repeated multiplication. So instead of saying 5 times 5 times 5 all the time, we can say 5 to the third. And then, of course, you want to go one step further here and evaluate 5 to the third, and this would be 125 just by doing the product here. And in case you guys may have forgotten, this raised dot here does mean multiplication. It's oftentimes more convenient to write that as opposed to writing this for multiplication. Because if I'm writing this, and I'm writing this as a variable, sometimes these guys can be confused for each other. Now, doing this or that for multiplication is I'm going to say that's fine. You just need to be consistent with how you write things. So that's going to be for multiplication. And that is going to be your letter. And if you write it more script-like, like this, you're not going to get it confused for the multiplication. Same thing for doing your variable y. It's a lot better to write it like this and not writing your letters x and y like that. You might say, well, that looks a little bit neater and cleaner. Yeah, but if you're going too fast, your x may become your y, and your y may become your x. So I say, let's not do that. Anyway, so we can even go further here. We can say, if I have 2 to the 5th power, and that just means that you have, you guessed it, 5 factors of the base 2. So instead of writing 5 factors of 2 all the time, we can say 2 to the 5th. And then we can just work this out. If you multiply all these 2's together, your product is 32. Now, if you think that's a cool number, what if you do something like 32 squared? Now, most people are familiar with squaring stuff. That means you just multiply it times itself, or you have 2 factors of that base. And 32 times 32 is one of the coolest numbers, which is 1024. I feel like I've seen that number somewhere before. Never mind. We'll get back to that. Alright, now one of the things you need to be careful about is negatives when it comes to powers. So understand that if you say negative 7 squared, that's not the same thing as saying negative 7 squared like this. A lot of times students will tell me that it is the same, or they will tell me, oh, my calculator's got it wrong. No, your calculator does exactly what it tells you to do. We're going to see that here in just a moment. This little negative right here is going to happen after you take care of the square. So the order of operations here is going to say, keep the negative here, and now you're going to work out 7 squared, which is 49. And so that gives you negative 49 as a result. The important thing is understanding that the square does not affect the negative. The square is only on the 7, and that's it. As opposed to this, by having the square on this set of parentheses, that means that is what's going to be repeated, which means not just 7, but negative 7. So negative times negative gives you a positive 49. And the sooner you learn the difference between those, the sooner you're going to be headed to success when it comes to math. Now let me show you what happens on the graphing calculator when it comes to this. Okay. So again, a lot of students think the calculator knows everything, but again, the calculator only knows what you tell it. Okay. So if you type negative 7 squared, well, it does tell you negative 49. As opposed to doing negative 7 in parentheses and then squaring that, so you get a positive 49. So, again, you just got to pay attention to how you use your calculator. Now, I hope that you guys can hear me. I hope I haven't been talking for the last 9 minutes and just been writing and no one can hear anything. So, if anybody can hear me, just say something in the chat so I know that I'm not just speaking into nothingness. One of my biggest fears. Okay. Oh, perfect. Thank you, Tone. Thank you for stopping by. Yay, we can hear! We haven't lost our hearing. That's great. Greetings, Marissa and Ghost Killer. That sounds incredibly scary, but although, wait a minute, I guess if you're a Ghostbuster, then that's a legit thing. And Toy, thank you guys for stopping by. I'm glad you can hear. Right, so basics of exponents. Now, I know that if I ask you this, you're going to go ahead and tell me what the answer is or how to do it. But if you've been in my class, and I know some of you have been, you know that just knowing the answer is not good enough. So if I say x squared times x to the third, and I ask you what the answer is, I'm sure you're going to tell me x to the fifth power, which is true, but then my follow-up to that is why? Why is it that way? Well, one of the things we need to know about this is what these guys mean. So as we talked about it before, x squared means x times x. And x to the third means you have 3 more factors of x. And so when you look at this all together, put my equal signs here, I've got to make sure I use my equal signs correctly. All of this together is connected through multiplication. It's all factors. And so you've got 2 factors from here, 3 factors from here, and all together that gives you your 5 factors. So I'm sure you guys remember a long time ago the rule that when you multiply, you add exponents. Well, this is why. And so we formalize that in the product rule for exponents. Now, yes, I am going to say the product rule for exponents as opposed to just saying the product rule. That being, you see product rules for radicals, you see product rules for derivatives and integrals, so keep saying that over and over, so we just want to be specific and say for exponents. So just in general, we have this. If you have x to a power times x to another power, of course the rule we say is that you would just add those powers. But now it's not just something that we have memorized, we see why it works out that way. 2 factors of x, 3 factors of x, altogether 5 factors. Now what I don't want people to do is I don't want you to then count all of these up. I don't want you to write out all 5 and then count them up. That's going to take way too long. Which again is why we have the product rule. So if I give these instructions, if I say simplify, and I do x to the 20th times x to the 47th, the last thing I want you to do is to write out 20 factors of x and 47 factors of x. That is just ridiculous. Instead, we've got this product rule which says you would take those powers and add them together. So it gives us x to the 67th power. That's it. Nothing too much more than that. Now, a lot of times you guys probably won't even write this step. You will look at this and say, okay, off to the side, I need to take these guys and add them together. So if I were to give you this, I say y to the 21st times y to the 15th times y to the 3rd. What do you think the answer would be? Throw it there in the chat. Let's see what you guys come up with. I mean, I don't want to be the one having to do everything this whole time. I'll give you a hint. There's a y involved. If you want to show powers, you can just use Shift 6 to get the little power symbol. Cool beans. Yes, fantastic, y to the 39th. And thank you guys for saying just y to the 39th. Because I've had in the past students try to, I don't know, they see this like there's a 1 in front of this, which is true, there is a coefficient there, but you're not going to do anything with the coefficients. I mean, if you wanted to, you could say 1 times 1 times 1, which is still 1, but it's really unnecessary to talk about that. Instead, you just want to take those powers and add them together. So if you want to create one of my classic little thought bubbles to make sure you understand what you're doing, you're taking 21 plus 15 plus 3 to get 39. Now again, 39 is not the answer. It's y to the 39th to give you the full thing. See? Simple. How can we possibly mess that up? All right. So there's that one guy that I'm sure you guys remembered. And what if we add something like this? if we then say x squared to the third. If I were to ask you, what are you supposed to do when you have a power that's then raised to another power? And somewhere in the back of your mind, like an old street address that you have memorized, you'll tell me, oh, when you raise powers to powers, you multiply. And so we'd say, yes, 2 times 3 gives you 6. But doesn't that seem weird? Why is that 6? How do we get 6 from that? Are you going to tell me it's just because that's what they taught you? Well, let's make sure we understand. That's what I want to get across to not just random people that are on the internet, but especially my students. Don't just do it because that's the way it's done. Try to understand, because once you understand, then you can do a whole lot more with that. So here's the reason for this. When you look at this, this is x squared to the third power, which really means you have 3 factors of x squared. Each of these x squares means you have 2 factors of x. So you've got 2 here, 2 here, and 2 here. So you have 3 sets of 2. And when you have 3 sets of 2, that leads to multiplication. If you've got 3 pairs, you have 6. So that's how we get x to the 6th. We're breaking this down. We see that this is 3 sets of 2. And that leads us to what we call the power rule for exponents. All right, and so the power rule has to be set up like this. You've got something with a power that's then raised to another power, and as we know, that means we're going to be multiplying those guys together. So for example, if I have w to the 9th raised to the 7th. Maybe we should go ahead and reach for the calculator, right? Forget it. We don't need a calculator for this. Right? We're smart. We know our multiplication facts. The thing we want to make sure we understand about this is that you have 9 factors of w. KEKW. Keep everyone. No. Okay. Can anybody help me out with KEKW, or do I have to look that up later? Wait, yes, we do. What? We need calculators? We need calculators for some things, but not everything. But if you want to grab a 4-function calculator, that's great. So you have 9 factors of w, but you've got 7 sets of 9. So 7 sets of 9 means that you have 9 times 7, and we have w to the 63rd. Let's do another one. If I have a to the 4th raised to the 13th. All right, make it easy. Let's see what you guys have in the chat. Oh, don't worry, they're going to get worse. These are the nice, easy ones. These are the ones that you do whenever you're sleeping or brushing your teeth. All right. So you have, there we go. Thank you, Marissa. Oh, she beat you to it. All right, so yes, you have 4 factors of a. You've got 13 sets of 4. So 4 times 13 is 52. I know that guy's kind of off of that normal 12 by 12 multiplication grid that we would have learned a long time ago. The only reason I really know the 4 times 13 is because I played a lot of cards when I was growing up. Not like poker or anything like that. I played a lot of just card games with my family. It's crazy. We used to play games together. All right. Power rule, product rule. Let's put these guys together. Oh, keep forgetting where my top of the screen is. All right, so what if I do this? I'm going to take m to the 11th to the 5th times m to the 7th. Now, one of the things I really like about these exponent problems is that for the most part, almost everything's going to be connected somehow through multiplication. They're all stuck together. There is order of operations you have to worry about, but really not too much. What you have to understand is that this m to the 7th doesn't get to be combined with what's going on here until you've rectified and you've resolved this part right here. So, the first thing we're going to do is recognize we have power to a power. You are viewing the example. So once you click Ask My Instructor, maybe that'll get you better results. I just had a good idea. Thank you for that. So here, we're going to do this first part. Oh, Tone, why the question mark? Let's work on having confidence. So power to a power, we're going to multiply these because we have 5 sets of 11, so it's m to the 55th. And then we have m to the 7th. And so now we have multiplication. You have 55 factors of m connected with 7 more factors of m. Don't multiply these guys. Understand that this is 55 m's together, connected to 7 more m's. So we're going to add those powers, and we get m to the 62nd. Yes, I agree. Confidence is very important. Flip. A lot of times in my class, I ask questions to students, and they will respond with a question mark. Even if I ask them what is their name, and they go, Jennifer? It's like they don't even know what their name is anymore. All right, so let's do this. A to the 7th, b to the 5th power times a to the 6th, b to the 21st. All right, so what we need to understand in this problem is that I've got this multiplication between these two terms, but these guys also have multiplication in between them. You've got factors of A and factors of B, and the great thing about multiplication is that you can rearrange these guys in any order that you want. And so really it just comes down to this. It comes down to identifying how many total factors of A do we have. You've got 7 here. You have 6 there, so altogether there are 13 factors of A. And then when it comes to the B, you get 5 here, 21 there, and we get B to the 26th. Yes, Nightwolf, perfect. Although, man, you guys are going to think I'm completely anal about this, but I would say don't use a capital A when I'm using a lowercase a. And the only reason I say that is because sometimes you might see a capital and a lowercase of the same letter, and you don't want to get those guys confused. Okay, and if any of you here have ever done stuff with my math lab, you know that sometimes my math lab can get persnickety. Oh, you guys going to start fighting? Come on, let's be nice. We're a friendly competition. Don't be like the Astros and make it unfriendly by stealing signs and other stuff. Oh, sorry, just kidding. I shouldn't be talking about sports. All right. Okay, cool beans. Well, thank you for joining on your phone. All right, so here is this. Oh, goodness. This is just as bad as being in my class. Not going to get anything done here. So what if I have x to the 5th over x squared? What do we get here? Oh, we're doing division, so that must mean... Oh, you think I'm nice? Oh, well, I'm not always nice. I'm just being nice for the internet. If there are any of my current students in the chat, you might need to set Flip straight about being crazy. Am I crazy? A simple yes or no will do it. You don't need to elaborate. Am I crazy? So, when you do division, as long as these bases are the same, you can subtract those powers. But again, my question is, why do we get to... Marissa, don't answer that. Well, nice to have you here, Kalia. Or should I call you Toy? Yeah, I guess it's up to you. All right, so remember what x to the fifth means. It means you have, you have 5 factors of x in the numerator, and in the denominator you have 2 factors of x. So the reason that that rule is that we get to subtract the powers is because when you look at this and you start to reduce, these guys get to reduce because it's one factor over itself. So they reduce to give you a factor of 1, which we don't need to worry about writing. It's just a factor of 1. Who cares? And here, you have another pair that reduces, and you're left with another factor of 1. So altogether, the only factors that remain are the 3 factors in the numerator here, x to the third. Yes, Flip, we can say cancel those x's, but I really want to make sure that we understand that we are not canceling them as much as we are reducing and simplifying, because a lot of times, all right, see you, Marissa, thanks for stopping by. A lot of times whenever students say they cancel, they expect them to go to 0. But what we're showing here is that they reduce to give you a factor of 1. It's a subtle yet very important difference. So when you look at this, I think of it more like a battle, like a struggle. You have 5 factors of x on the top, 2 on the bottom, and really it comes down to where do you have more factors of that variable. And when you think about it, you have more factors of x in the top than you do in the bottom, and then I would ask the question, how many more factors of x do you have? You've got 3 more factors of x, which means that if I were to flip this around and I were to say x squared over x to the fifth, where do you have more factors of x? Well, you have 5 in the bottom, you only have 2 in the top. So that the reasoning here is that you have more factors of x in the denominator, and I would ask the question, how many more factors of x do you have? Well, the difference between 2 and 5 is 3, so you have 3 factors of x in the denominator. But you can't leave the numerator empty. So we put a 1 right here. And this 1 is the same thing as the ones that you have here from reducing before, except now the whole denominator, the whole fraction is flipped over. Okay? And now there's a reason that I'm showing this to you because of what we're going to be seeing here in just a moment. So, Flip, you say you haven't taken math in a long time. How long is a long time for you? I know that some of my students, they've been out of school for maybe a year or they took their senior year off. Some of them have been out for 20 plus years. So I was wondering, how long ago has it been for you? So what I just showed you here leads us to the quotient rule for exponents. And again, so it's what you guys would have said anyway, that if I have x to the a over x to the b, you're going to take those powers and you're going to subtract. Now, if you look at the rules that we have here, you'll notice that these guys are the same variable. If you come back to the product rule that we did on the other page, these guys were the same base. The same base right here is going to lead to that common base there on the right side whenever you simplify. So we have to have that, or else we just can't do it, because we wouldn't have factors to combine or factors to cancel out or reduce away like we have up here. Oh, your last math class was first. Okay, wow. So I guess are you about to graduate? What's your degree? And how are you guys, or how is your school handling all the coronavirus stuff? Are you guys shut down for the rest of the semester? Or what's going on for you guys? Just kind of asking out of curiosity. I know that I was talking with someone in chat a day or two ago, and all of the like 7 different colleges and institutions for Indiana University are shut down for the rest of the semester. That's like Indiana University, I guess the other branch schools as well. Well, you know what, Marissa? Does anybody like going to class? I mean, do I like going to class? Nah. As I say in class, it's all about the Benjamins, you know what I mean? I'm so sorry. I shouldn't be doing this. I should be having a more professional type persona when I'm out here. You know me. They don't know me. Now I'm going to start crying because we're making it awkward. Oh, man, that sucks. Well, hopefully it all works out for the best and that, you know, the online classes will work out well. I've never taught online, but I'm afraid that, well, we'll just have to see how things go. We might end up doing some online stuff, so we'll see. In my 10 a.m. class. Okay, so now I'm going to have to figure out, oh, wait a minute. So now I feel like it's a guessing game to figure out who you are. Yeah, online stuff is so hard, especially for a math class. I don't see how a lot of people do it. I've been thinking about how could I present math in a way online so it would still be doable for a lot of students, but I still think most of the students that I have, they need that hands-on experience. They need to have the instructor right there or be able to stay after class and ask questions or to be able to see it in multiple ways. Hey, Ghost Killer. Well, you say the 8:30 class, but there's Monday, Wednesday, and there's Tuesday, Thursday. So coming back to this problem, where you have more factors of x, you have more in the top, and it's just a matter of really going off to the side here and figuring out, okay, what is 22 minus 8? And of course you get 14. Well, I hope Marissa gets her work done. She'll be getting more and more emails from me as the semester goes on. Thank you for stopping by, Flip. Hope you have a good rest of the semester and things go okay. So here we end up with x to the 14th. And everybody's all happy with that. So what if I do this? If I say a to the 10th over a to the 17th. Well, then it comes down to being, I will do my best. You too. When I come to this problem, where do I have more factors of a in the top or the bottom? Because that's where the answer is going to be. You see that we have more factors of a in the bottom, so in my fraction, that's where they're going to be, and I have 7 more factors of a, so that's where they remain. Which means I'm going to have a 1 in the top. What you have to make sure that you understand is that you cannot leave the numerator empty. There must always be something in the numerator. And you might say, well, what about this problem? Well, we had more factors in the top, and if you wanted to, you could say, this is kind of ridiculous, but you could say this is x to the 14th divided by 1. But why do I need to say divided by 1? That doesn't do me any good. So that's why we just say x to the 14th. Yeah, and see, there's the thing, you're saying x, and I know that if you go into my math lab and you're in this x mode, and you type in x when it should be a or b or p or q, because they do stupid stuff, you're going to get it wrong. Especially when you click similar exercise and they change the letters on you, and then you're totally messed up at that point. That's just my math lab messing up on you. Sorry, I may have had too much to drink today. I'm just kidding. Just drinking water. So hydrating. Make sure that you guys do stay hydrated. Make sure that you stay safe out there. Please make sure that you wash your hands. Stay away from people. I know a lot of you are young, but not everybody is as young as you are. And we don't need to be spreading any kind of viruses or germs to those people whose immune systems are not as strong as yours. So please kindly accept that little PSA. All right. So here's one of the things we need to understand about negative powers. And this is where I tend to lose a lot of students. And the negative powers is not just in this exponent review, but we're going to be seeing a lot of this later on this semester. I don't know why. I like powers. Powers are just so much fun for me. So here is a neat little rule. If you have x to the negative nth power, this means 1 over x to the nth. Or, if you have a negative power in the denominator, you can flip that over and make it a positive power like that. And that's really the key thing to understand here, is that when you have a negative power, you're just going to be doing the reciprocal with that. For example, if I need to evaluate 4 to the negative second power, that power is very difficult for me to interpret right now, because I can't say that I have negative 2 factors of 4, because typically I'm using my power as a way to count how many factors I have. And when we count, we don't deal in negative numbers. So what we do is we use this little statement right here that says 4 to the negative second really means 1 over 4 squared. And once I have it written like this, it's really easy for me to evaluate this and say 1 over 16. That's it. No big deal whatsoever. If I have 7 to the negative third power, that negative power is going to flip me over and say 1 over 7 to the third power. And then all we do, oh, and I don't have my power sheet. I bet some of you have your power sheet. But you know what? I can handle this even without my power sheet. Let's be brave little toasters. 7 to the third means 7 times 7 times 7. And so as I combine these guys one piece at a time, that gives me 49. And the 49 times 7 is 343. Ah, you got me there. Good job, Ghost Killer. And so this is 1 over 343. So, let's just verify, because I know that you guys don't believe me. Why should you? So let's go to the calculator. The first guy we had was 4 raised to the negative second power. And that gives me 0.0625. Well, what does that mean? Remember that you can easily convert your decimal answers into fractions as long as they are rational numbers by pressing math and converting that to a fraction. So we hit enter, and we hit enter a second time, and that tells me 1 over 16. I can do the same thing for the second example, 7 to the negative third. Again, it gives me a crazy decimal. Don't care so much about that. Convert that to a fraction by going to math, and I get 1 over 343. Okay, so you see that what we have here is verified by the calculator, the one thing that you hold and cherish above everything, like toilet paper. And I wonder if people will find this video in a few years, if they will understand how that makes sense. I really shouldn't be making light of toilet paper and all this other stuff, but you know me. I use humor to get away from the things that are serious. Alright, so things are easy so far. I want you to see this. If I have the fraction 2/3 raised to the negative first power, the negative right here indicates that we need to do a reciprocal. And remember that a reciprocal means taking the fraction and flipping it upside down. So, by applying the negative here, it's going to take the 2 over 3 and make that 3/2 and raise to the first power. Of course, if you raise anything to the first power, well, you just get itself. It's just 3 over 2. And speaking of that, just a few housekeeping things that we need to make sure we understand. Anything to the first power is just going to be the base itself, a. Anything to the 0 power is going to be 1, provided that that base does not equal 0 itself, because 0 raised to the 0 is undefined. So those little tricky guys, a lot of times people think that 0 to the 0 is 0. No, it's undefined. And all the stuff that we have here with powers, for any of you guys that are my current students, we're going to be coming back and hitting this really hard in a few weeks. It's going to be after your next test. Wait, yeah, because we're going to be dealing with exponential functions, and they're going to be based purely on powers. So we have to understand what those powers are so that we can graph those guys. Well. All right, let's try to put all this stuff together and see what we can come up with. If I take x to the 6th to the negative 4th power, the first thing that we need to recognize here is that we have a power to a power. And when you have a power to a power, that means you have to multiply those powers. So 6 times negative 4 is just negative 24. But we don't stop here. This is not good enough because we have a negative power. And anytime we have a negative power, we need to rewrite this to be a positive power. And as we were showing above, we just do the reciprocal. So it's 1 over x to the 24th. That's it. That's all that we have to do. I know you're thinking that's kind of boring. Don't things get any more exciting? Well, let's try this. A to the 7th, b to the negative 4th, to the negative 3rd power. Now, one of the things we didn't mention yet, well, at least on this stream, is that you have a product here. And one of the properties that we have is that when you have a power that is applied to a product, that means that each factor receives that power. And the same thing is also going to work if you have a quotient. So if you have x over y, and the whole thing is raised to the a power, then that power gets applied both to the numerator and to the denominator. So if I look at this guy right here, I'm going to raise each of these factors to the negative 3rd power, like this. Now, the more of these you do, the easier it is to see how we can go straight from here to our final answer, or our almost final answer. So power to power, we multiply. 7 times negative 3 is negative 21. Negative 4 times negative 3 gives me positive 12. I want you to see that the only thing I'm really asking you to do here is to raise a power to a power, which is to multiply two integers. Nothing crazy here. What you have left to do is to pay attention to your signs. A positive times a negative is a negative, and the product of two negatives is a positive. But we're not done. And it's all because of this little guy right here. Don't leave an answer with a negative power. The only time you leave negative powers is if you're dealing with something, say, with scientific notation. But we're not doing that here. We're just dealing with powers and variable expressions. So this guy has a negative power, so we're supposed to flip him over, kind of like I did here in this last example. But what do I do with the b to the 12th? Well, this guy's going to kick into the denominator, so it's a to the 21st, positive 21st power, and the b to the 12th is going to stay exactly where it was, in the numerator, just like this. Now, to maybe give you a better idea about what we're doing here, let me just go to something that would have been towards the end of a problem, okay? If I were to say a to the negative 4th, b to the 3rd, over c squared, d to the negative 7th. If for some reason your final answer led to this, we have to make sure that we address the issues with our negative powers. So this guy has a negative power, and this guy has a negative power. That's it. Those factors that have a positive power are going to stay exactly where they are. You don't move this guy, and don't move b. Leave them exactly where they are. A to the negative 4th has to go to the other side of the fraction. And the same thing has to happen for d to the negative 7th. He's going to take a ride up to the numerator. So when I rewrite this, we did not move b to the 3rd, and we didn't move c squared. They stay exactly as they are. A to the negative 4th, when it goes into the denominator, becomes a to the positive 4th, and d to the negative 7th, as it goes to the numerator, becomes d to the positive 7th. So that's where you're going to, that's where you're going to take care of those issues with negative powers at the very end of a problem. So again, this was just, if we're playing around with the negatives, what's going to happen if we have them at the end of the problem. All right, let's see. Oh, you want to put a bunch of these concepts together for one like big problem so that you can show off to your friends. Ah, sure. That's what we all want to do. All right. So let's take x to the negative 6th, y to the 5th, over x to the 8th, y to the negative 2nd, all raised to the negative 10th power. All right, so you have a couple of options here. You can choose to simplify what's inside the parentheses first, or you could go ahead and apply this power of negative 10 to every piece that's in here. See, these guys are all connected through multiplication and division, so it's pretty easy to just go ahead and apply that to everybody. Tell you what, we're going to do it two different ways. First, let's just go ahead and raise everybody to the negative 10th power, and let's see what happens. You know, I could be wrong. Maybe I don't know what I'm talking about. So here I'm going to have negative 6 times negative 10, because that's power to power. It's going to give you x to the positive 60th. You're going to have y to the negative 50th. And this is all divided by, get down here into the denominator, that's x to the negative 80th, and y to the positive 20th power. So far, so good. We just need to take care of those negative powers. All right. So x to the negative 80th needs to move to the other side of the fraction, and y to the negative 50th needs to go to the other side as well, except he was in the numerator and he goes to the denominator. This x to the negative 80th is going to move up to the numerator. You know, if you've got the colors, use the colors so you see where everything goes. So x to the 60th stays where it is, as well as y to the 20th. Please don't tell me, oh, I thought this guy moves because he's connected to this guy. Understand that this power of negative 50 is only connected to the y, nothing else. So x to the 60th stays where he is. So this guy here in pink, x to the negative 80th moves up to the numerators, x to the positive 80th. And y to the negative 50th goes into the denominator, so that's y to the positive 50th. So now that we've addressed all of the negative power issues, it's now time for us to figure out where do we have our variables. So you can see here that we have all of the x's in the numerator. So we're just going to combine those guys because they're on the same side of the fraction. You have 60 and 80. So altogether we have x to the 140th power. In the denominator you have 20 factors of y and 50 factors of y. So we get y to the 70th. And that's it. There's nothing else for us to simplify. Please don't look at 140 and 70 and think, oh, I'm going to reduce those. You can't do that because these bases are not the same. So it has to stay just as it is. Now, suppose that you took a different route here. So I know that there are some of you out there who would prefer to take care of what's inside the parentheses first? After all, it sounds like part of the order of operations, right? So let's do that. Inside here, I'm going to take x to the negative sixth. He's going to go downstairs, and y to the negative second is going to move up into the numerator. This power of negative 10, I'm not going to worry about him just yet. I'm just going to bring him down as part of the problem, and later on we're going to address that. All right, so y to the fifth, x to the eighth. X to the negative sixth becomes x to the positive sixth in the denominator, and y squared in the numerator. You might say, this does not look right because we had x's in the top before, now they're in the bottom. We're not done yet. Let's see what happens. When I combine what's inside here, all of my y's are in the numerator. You have 5 factors here with 2 more factors there, so you have 7 total factors of y. In the denominator, 8 factors of x and 6 factors of x will give us 14 factors of x. And then we raise this to the negative 10th power. And so now we finally get to take care of that negative 10th power. So this is where we do a power to a power and we multiply. So y to the negative 70th over 14 times negative 10, so that's x to the negative 140th. Well, see, so now we have more negative powers to deal with. But again, it's pretty simple. You're just going to take these guys and flip them over because of their powers. What are you doing here? Sorry, my computer is wanting me to update things that I'm not ready to update. So when we finish this, this guy's going to move up to the numerator, so x to the 140th, positive 140, and y to the positive 70th in the denominator. So 2 different ways, and we get the same answer. So you really just need to choose which way works best for you. Okay. Now, I do want to go back to something we were talking about before. Suppose I do a big fraction like this. A to the 7th, b to the 9th, c to the 4th, all over a to the 5th, b to the 13th, c. Now, in a problem like this, all you have to do is figure out where do you have more of each of the variables. That's all you got to figure out. So if you look at the a's, and you know what, you might even want to do some little divisions like this. It's all connected through multiplication, but maybe this can help you see things a little bit better. If I look at just these a's right here, you see that you have more factors of a in the numerator. In fact, the difference between 7 and 5 is 2. So if you were to write out all 7 factors of a and all 5 factors of a, they'd all start crossing each other out until you were left with just 2 factors of a in the numerator. And when you look at the b's, you see that between these two, between the numerator and denominator, you have 4 more factors of b in the denominator. So we've got to make sure we address that. So it's over b to the 4th. And then finally, when we look at the c's, I've got 4 up here, but what about this guy that doesn't have any power explicitly written? Well, that's understood to be c to the 1st. And so when we look at this, where do you have more factors of c, top or bottom? We got more in the top. And you have 3 more factors in the numerator, so there you go. That's all there is. Nice and simple. So let's do this to try to finish up this little stream, at least for the first stream. Make it a good solid hour here. I'm just going to give you some problems, and I want you to tell me in the chat what you come up with. All right, so let's do x to the 8th raised to the 7th. Let's see who's fastest on the keyboard. Da-da. Cool beans. There you go. So power to power means we multiply, so we get x to the 56th. Perfect. But what if I do this? I say it as though it's going to be something different, but maybe it's the same. Who's going to be first? Marissa, Tone, Toy? Wait a minute, did I do something wrong? Nightwolf, were you responding to the last problem or this problem? Alright, so here's what we need to remember. This is multiplication, right? And what are we supposed to do with powers when it comes to multiplication? If you remember the rule, it says that when we multiply, we're supposed to add. But to me, that sounds so crazy to say that out loud. When you multiply, you add. That's like, addition by subtraction. It's a ridiculous thing. Think about it like this. You have 8 factors of x. You have 8 little x's all strung together, connected to, imagine like a coupling, and you're going to string that together with 7 more x's. You've got 8 x's here, 7 here. How many are there all together in that product? There's going to be 15. You're going to add those guys. That's why there's addition. As opposed to the last problem, you have 8 factors of x right here. But the 7 says you're going to have 7 sets of 8. So how should I think about this? If you're doing exercises, and you're doing an exercise where there are 8 reps, but you're going to be doing those 8 reps 7 times, how many times are you going to be doing that exercise? Oops. You're going to end up doing it 56 times because you're doing 7 sets of 8, 7 groups of 8. As opposed to here, this is more of, I'm going to do 8 reps here, I'm going to do 7 reps here for a total of 15 reps. And that's it. There's no 2 or anything that goes in front of this because you're not going to add those coefficients. If anything, think about it like this. That's a 1, that's a 1. I agree with that. However, this is 1 times 1, so it's still going to stay 1. And we can kind of ignore that as a coefficient. Alright. So x to the 8th over x to the 7th. So now we're doing division. And this is where you have to remember to compare. Where do you have more factors of x, the top or the bottom? And wherever you have more of those, that's where the answer is going to be. So you have more x's in the top, and as Tone is saying, it's just x, right? You could say x to the first, but I don't need to write that. Again, I can. I wouldn't count off if you did. I would just be like, well, you didn't totally simplify. But we've got to make sure we understand where the numbers are and what their meanings are. So if I say 7x plus 8x, right? And this is like really old school. So 7x plus 8x. And while you're thinking about that, while you guys are, with the lag from me saying this and the different people seeing this on your end, compare this compare it to 7x times 8x. Right, so I mean, you look at this, 7x plus 8x, they're like terms. And remember, when you have like terms, that's because you are identifying that their variable pieces are exactly the same as just x, which means you are sitting here trying to figure out, I've got 7x's and 8x's, all together I have 15x's. Okay, that's it, you're just counting them. Oh, okay, Marissa, you're jumping on to the next one. Okay, cool. Here, this is multiplication. It's all connected through multiplication. So it's not 7 plus 8 like it does up here. It's 7 times 8. Remember, with multiplication, the order doesn't matter when you multiply. So we get 56. But now you've got two factors of x. X times x is going to give you x squared. So 56x squared. Okay, let's try another one. So let's take this guy and compare it to this example. All right, so what do you say about these two? So now I got to think about what math concept I should stream next time. I'm going to put a poll out on Twitter. At first I thought it was going to be quadratic equations that was going to win. I'd also tossed out synthetic division, which you guys that are in my class are going to be seeing here in a little bit. That's like one of the next big concepts that we have. I also said factoring trinomials, which you guys know me and you know how I love to factor. And remember, if you guys are ever trying to find me anywhere, you always find me at mathman1024. Again, like I showed at the beginning of the stream, 1024, that's 32 squared. When's the next stream? You know, that's a very good question. Maybe in a couple of days. We'll just have to see. I'm still waiting to see what's going on with my work, to know how I should be teaching the rest of the semester, and if I need to set up virtual office hours so that may or may not come in conflict with this. We'll have to see. If I can do this every couple of days, I think that'd be good, and just find some good stuff to stream. I actually did toy around with the idea of doing fractions, just spending a whole session doing fractions and trying to make it as simple and easy as possible. But if you guys want to, you can, if you follow me on Twitter, I tend to kind of post earlier in the day when I'm going to be doing a stream. Of course, if you follow me here on Twitch, you'll get the notifications if you sign up for that. All right, so I see Nightwolf has given us a couple of answers, which I kind of... Oh, Marissa, don't be afraid of fractions. I can make them, I don't want to say I can make them go away, like I'm in the mob or something. I can make them easy for you. All you have to know is your basic adding, subtracting, multiplying, and dividing. That's it. Finding a common denominator, I can make it super easy. But you just have to trust me. All right, so let's go back to these. You know what? I'm going to do this one first, because this is the easiest one. Again, you're multiplying. 7 times 8 is still 56, in case you guys forgot it from previously. You have 8 factors of x connected to 7 factors of x. So altogether, we still have 15 factors of x. But what about the one that I had above it? This guy right here? You cannot simplify. Can't even believe it, right? You can't simplify that because these guys are not like terms. You might say, but they both have x. It's true they both have x, but remember the thing about adding. See, multiplication is one of my favorite things because you don't need terms to be alike. You don't need common denominators. You just put them together. Like down here. These guys are not like terms, but I can still multiply them. However, when it comes to adding, you have to have like terms. Just like when you add fractions, you have to have common or like denominators. Up above here, we can add these guys because these guys were the exact same variable expression. These are not. This is x to the 7th, and this, however, is x to the 8th. So since they're not exactly the same, we can't do anything with that. We're done. Cannot be simplified. Now, to kind of go on along with what I'm saying there, if I were to say 5 x to the 7th plus 3x to the 7th, I gave you this as an example. Since these guys are exactly the same in terms of their variable components, all you have to do is combine their coefficients, which gives you 8 x to the 7th. So x to the 7th plus x to the 7th is going to yield x to the 7th. It's the same thing if you were to, maybe you're talking about your home and you're going to be doing an addition on your home. Suppose you have a home that is 1,500 square feet and you're going to be adding 200 square feet. Since these units are exactly the same, not just feet and feet, but square feet and square feet, they're both measuring area of the same unit, you could combine these guys to get 1,700, and you're still talking about square feet. Notice that the unit didn't change. Square feet plus square feet is square feet. What you can't do is this. You couldn't say 1,500 square feet plus 200 feet, because this measures area, but just 200 feet measures a length, and you can't add those guys because they're not the same type of unit. So, thank you guys for stopping by. Hope you learned something, hope you remembered something, and hope you come back again. It's great to have you here. Kind of miss having my classes. It's been so long, and I've only been able to get on to my kids. I need to be getting on to you guys too for not doing your homework and stuff. But if you're my students, look for emails from me. If you're not, come back, bring friends, bring questions, and yeah, Marissa, fractions. That sounds like a wonderful time. So, have a good night, guys. See you, Tone. Oh, you're welcome, Ghost Killer. Good night, guys.